Okay, question 28. 40 pupils helped to sell packets of popcorn at a school carnival. Each pupil was given 6 packets of popcorn to sell. Some did not turn up, so each pupil present had to sell 2 more packets to meet the required sale. How many students did not turn up? Okay, so firstly, there were 40 at first, right? But each pupil was supposed to sell 6 packets. So the total number of packets that they had to sell would be 40 times 6. Okay, 240. So no matter whether you have pupils not turning up or not, your total number of packets to be sold has to be 240. So because there were some that did not turn up, right? The rest of it has to be redistributed. So in the end, each of them, okay, each in the end would be 2 more. So at first it's 6, then 2 more, it becomes 8. So everyone has to sell 8. So how many were there? Number of pupils in the end. So if you had 240 to sell, and each of them had to sell 8, there will be 240 divided by 8. Means that there's 30 of them. So if the total is supposed to be 40 pupils, the number of pupils that did not turn up would be 40 minus 30. Okay, so 10 of them did not turn up. Question 13, the printing rates of 3 machines ABC are shown. At 11 o'clock, Gwen started to print posters using only machine A. Half an hour later, while A continued printing, she started printing posters with B and C as well. So how long would B and C take to print the same number of posters as A? Express your answer in hours and minutes. Okay, so firstly, A started first, right, for half an hour. Let's find out what's A in half an hour, in 30 minutes. So A in 30 minutes, or half hour. So it's 360 divided by 2, which is 180. Okay, so A started with 180 at first. Then when B and C started printing, right? Okay, the question is asking for B and C, asking how long it will take for B and C to print the same number as A. So for B and C to print the same number of A means that there is a like a catching up to do, right? Because A already started with 180. Okay, let's find what is A and B combined. So in 1 hour, B and C in 1 hour. B plus C 1 hour. So we're finding like the combined rate first, since both started printing together. This is 410. So in 1 hour, B and C can print 410 posters together. Now, you know A started first. A had a head start of 180, right? Do you think B and C can ever catch up with A? The answer is yes, because if you compare in 1 hour, right? If you compare B and C, they can print 410. But for A, it prints 360. So there is a chance for B and C to catch up to be the same as A, right? So in 1 hour, the extra that B and C can print. So we're looking at the difference. Difference in 1 hour would be 410 minus 360. So every 1 hour, B and C can catch up by 50 posters. But the extra that B and C needs to catch up by is this 180 that A started with. So how long does it take? So time taken to catch up by 180, right, would be 180 divided by 50. Because 180 is the total that it needs to catch up with. 50 is what it can catch up with within 1 hour. So by dividing this, you are actually finding the number of hours. So this is 3 3/5 hours then this is the time taken. They're asking for the time taken. So this is the answer, but you need to express it in hours and minutes. So 3 and 3/5 would be 3 hours. 3/5 hour, you have to change to minutes by multiplying it by 60, because every hour is 60 minutes. Okay, so 3/5 times 60 is 36 minutes. So this is the time taken for them to print the same number. Okay, this is the time taken for B and C to catch up with A. So yeah, in other words, it's printing the same number of posters.
Move up to question number 6. A class of 25 students were each offered a box of donuts to sell during a fun fair. 3 of the students could not sell any of the donuts, so they passed their boxes of donuts to the rest of the classmates to sell. As a result, each of the remaining students had to sell 6 more donuts. How many donuts were there in each box at first? So the remaining number of students who are selling, the remaining number of students remaining number of students who are going that are selling will be 25 minus these 3 students that could not sell anything. So only 22 students are selling. There are 3 students not selling, okay? Only these 22 students selling. And these 22 students are also selling the boxes of donuts that belongs to the 3 students. All right? So each of these remaining 22 students have to sell additional how many donuts each? They have to sell additional 6 donuts each, right? Each of them have to sell 6 donuts each. So these 22 students have to sell a total of 132 donuts. And these 132 donuts came from the 3 students. Okay, got it? These 132 donuts came from the 3 students. Now, one of the students will be having 44 donuts. So 132 donuts came from the 3 students. So each of the 3 students are actually supposed to sell 44 donuts. And that is 1 box. Because the question says that each offered a box. So if each student is supposed to sell 44 donuts, and they are supposed to sell 1 box, it means that 1 box contains 44 donuts. So the answer is, how many donuts were there in each box? 44. Any question? This question 6, this kind of questions we have done it a few times in our select paper. So it's not common in primary 6, but very common in primary 5. So yeah, if you revise your work, you will know how to do this. It appeared a few times in our select paper. Let's look question number 7. Commonly tested. That's why I do so many. Okay, this one is another question that we have done a lot of times. Plenty of times. Okay. He bought an equal number of keychains and trading cards. Equal number is a keyword. Okay. So now we know that the keychains must be bought in 4s. No way you can buy 1, 2 keychains. Once you buy, you must buy in packets of 4. Right? Trading cards the same. Each time you buy in packets of 3. Then, if he's going to buy equal number of keychains and trading cards, what's the minimum he must buy each? 12. Right? 3 packets of keychain and 4 packets of trading cards, or the lowest common multiple of 4 and 3. Understand? So that is a minimum James has to buy in order to buy equal number of keychains and trading cards, which is 12. So to buy 12 keychain, you need to buy 3 packets of keychain, right? So 4 keychain costing $17. 12 keychain means you need to buy 3 packets. So 3 times $17, he needs to pay $51. For trading cards, in order to get 12 trading cards, he needs to buy 4 packets of 12 of trading cards. 1 packet of trading cards give you 3 cards and cost him $8. Right? 12 packets of 12 trading cards, you need to buy 4 packs. So $8 times 4. You need to pay $32. Okay. Now, so this is the minimum he has to buy. One group, which is 51. Minimum is one group. He's going to buy in groups like this. Every group costing how much? 51 plus 32, right? Okay. Now, the questions provides that he spent $76 more on the keychain than the trading cards. So in every group, he paid how much more for the keychain compared to a trading card. Every group, I call it difference in one group. Difference in one group, in every group, James paid $19 more for the keychain than the trading cards. So every group, the difference is $19. The question provides that there's a total difference of $76. So every group, all the differences add up, must give you a total difference of $76. So obviously James bought many groups like this, and the total difference add up to $76. Many groups, difference in every group add up, give you a total difference 76. So if I use 76 divided by the difference in one group, I get 4. And 4 represents the number of groups James bought. Okay, number of groups like this. Let me use a color, different color. One group is like this. Okay, 12 keychains, 12 trading cards. So he bought 4 groups of this. Question is, how many keychains did he buy? In every group, there's 12 keychains. And he bought 4 groups. So 4 times 12. He bought 48 keychains. Any question? Okay, let's continue. So Ginny bought some pens at 180 each. Mary bought some notebook at 250 each. Jenny bought 9 more items. 9 more items than Mary and spent $5 more than she did. So there is 2 total difference. One is the quantity total difference of 9 more, and one is the value total difference of $5 more. So we need to do 2 models. So the first model will be a quantity difference model. So we have Jenny that bought only pens, and the pens is 180 each. Okay, so let's draw a model to represent the pens. Then we have Mary, who bought only notebooks at point MB. So that is Mary. Bought only notebooks MB. And we know that Jenny bought 9 more. than Mary. So make sure my Mary is shorter than Jenny by 9. Okay, so this is quantity. Now let's look at the value model. Okay, so these two Jenny and these two Mary. Okay, remember Jenny only bought pens. The statement says Jenny spent $5 more. So Ginny spent $5 more than Mary. So I'm going to draw Ginny spending is, sorry, $5 more. So draw Ginny spending is $5 more. Than Mary. Okay. Now the first thing we do is we need to remove these 9 pens from the quantity so that Jenny and Mary will have the same number of items. The value of 9 pens will be 9 times 180. That gives you $16.20. Let me figure out the price of the notebook is how much. The price of the notebook is $250. Let's put it at $250. So if I were to remove the 9 pens from the quantity so that I have equal number of pens and notebooks, I must also remove the equivalent value of these 9 pens. And the equivalent value of these 9 pens is $16.20. So I'm going to cut off $16.20 from here. $16.20. Cut it from here. Or from here all the way backwards, somewhere here. This will be removed. So what is left here will be equal to $16.20 minus away $5. You will get $11.20. So this portion is $11.20. So what that means is that after you remove 9 pens from John or from Ginny, the total difference in value will be $11.20. All right. So total difference in value will be $11.20. This is number. Okay. This is made up of equal numbers. This 1120 is the total difference between an equal number of pens and notebooks. The difference between 1 pen and 1 notebook, I call it the difference in one group. Is 250 minus 180. And that will give you 70 cents. So difference in one group is 70 cents. The number of groups $11.20 divided by 70 cents. And you get 16 groups. So there are 16 groups here. The question is, how many notebooks did Mary buy? So this is the answer, 16. Let's look at question number 10.
Question 13. Charlie poured pancake mixture into 2 types of containers with different capacities as shown below. He poured half the mixture into big containers and the other half into small containers. He filled the containers to the brim. Charlie used 24 more small containers than big containers. How many big containers did Charlie use? For this, I'm going to use something like the method we use for average, the redistribution concept. Okay, so let's write down, draw out what it looks like first. For the big containers, you can fill up 375 ml each. Okay, so we don't know how many of this, but this is how we represent it. Okay, so 375, many bottles, don't know how many. Then for the small ones, it's 75 each. So it looks like there's the same number here, right? So but there's actually 24 more small ones. So for the small, I'm going to add 24 times of this. So every circle represents one bottle. Now, because they said that he poured half into big and half into small, right? Technically, this whole thing will have equal volume as the bottom one. Okay, so the total for the top has to be the same as the total for the bottom. Now, if you compare left side, right side, on the right side, it seems like there's this extra, although we said the total volume is the same, right? So let's find out what is this 24 times 75 first. This will give us 1800. Now, if we compare the right side, it seems like there is this extra 1800, but not really. The top has to be the same volume as the bottom because it's half for the big and half for the small. So on the left side, it means that when you compare the top and bottom, there is a decrease of 1800 for it to balance. Okay, your total volume must be the same on top and bottom. So on the right side, if there's extra 1800, then on the left side, there must be a decrease of 1800. Now, every bottle decreases, there is a decrease of 300. So how many bottles are there? Remember I said the decrease has to be 1800. So if every bottle is a decrease of 300, then the number of bottles will be 1800 divided by 300, which is 6. So there's actually 6 times of this. How many big containers? 6 big containers. How much pancake mixture was there? Now using the big one, right, you can just find the volume for the big one and then you double it because that's basically half of the total. So 6 times 375 for 6 big bottles. This will be 2250. Then the total pancake mixture will be twice of that. 4500 ml. Okay, again, why times 2? Because the big and the small is actually half each. See, half into big, half into small. So you just need 2 times 2. You don't need to find out what is this because you will end up with 2250 again. All right. Okay, question 16. Miss Wong received 6,120 from selling some bags and some dresses. She received $3,240 more for the bags than the dresses. 4 times as many bags as dresses were sold. Each dress cost $15 more than each bag. How much did Miss Wong receive for the bags? Okay, so when we talk about the amount of money, right, what do we have? We have the total amount from selling everything, the bags and the dresses, and then we also have the difference in the amount. So basically, we are comparing the bags and the dresses. More for the bags. Okay, so this is what it looks like. Difference is 3240 The total is 6120. How much did she receive for the bags? So you take 6120 minus 3240, then divide by 2. That is for the dresses. Then you need to add 3240 to get the bags. So answer $4,680. How many dresses did she sell? Okay, so now what we need to do is to bring in the picture of the quantity. Okay, there are 4 times as many bags as dresses sold. So earlier on, we only talk about the value. So in terms of quantity, what I'll do is, I know the bags will be 4 times, right? So in this value model, I can't cut it into 4 because this one is talking about value. So I'll write here 4 groups of bags and 1 group of dresses, because the quantity for bags is 4 times. So what have we found? We have actually found 4 groups of bags as well as 1 group of dresses. So 1 group of dresses is 1440. 4 groups of bags is your 4680. Now I want to compare 1 group of dresses and 1 group of bags. Okay, I want to see what is the difference, because technically 1 dress versus 1 bag is difference is $15. So let's compare 1 group of dresses and 1 group of bags. So 1 group of bags will be 4680 divided by 4. 1170. Now let's compare 1 group of bags versus 1 group of dresses. 1440 minus 1170, which is $270. Now imagine 1 group of dresses. This is 1 group. And 1 group of bags. This difference here is actually 270. Dress costs more. Okay. So here is dress costs more, so minus 270. In this direction, it's a difference of 270. 270 less. The bag's 270 less. But every bag is $15 less. So here is minus 15. So if I take 270, I divide by 15, what am I actually finding? I'm actually finding how many sets of this 15s are there, right? Or in other words, how many items are there in 1 group? Okay, so number of items in 1 group. 270 divided by 15, which is 18. So every group, there are 18 items. Question is asking how many dresses did Miss Wong sell? Go back to this. She sold 1 group of dresses. So 1 group has 18 items. Answer is 18 dresses. Okay, so 18 times 1. Because there's only 1 group. Okay, this is the number of groups.
So Ginny bought some pens at 180 each. Mary bought some notebook at 250 each. Jenny bought 9 more items nine more items that Mary and spent $5 more than she did. So there is two total difference. One is the quantity total difference of 9 more, and one is the value total difference of $5 more. So we need to do two models. So the first model will be a quantity difference model. So you have Jenny that bought only pens, and the pens is 180 each. Okay, so let's draw a model to represent the pens. Then we have Mary, who bought only notebooks. I call it MB. So that is Mary. Bought only notebooks, MB. And we know that Jenny bought 9 more than Mary, so make sure my Mary is shorter than Jenny by 9. Okay, so this is quantity. Now let's look at the value model. Okay, so these two Jenny and these two Mary. Okay, remember Jenny only bought pens. The statement says Jenny spent $5 more. So Ginny spent $5 more than Mary. So I'm going to draw Ginny spending is, sorry, $5 more. So draw Ginny spending is $5 more. Than Mary. Okay. Now the first thing we do is we need to remove these 9 pens from the quantity so that Jenny and Mary will have the same number of items. The value of 9 pens will be 9 times 180. That gives you $16.20. Let me figure out the price of the notebook is how much. The price of the notebook is $250. Let's put it at $250. So if I were to remove the 9 pens from the quantity so that I have equal number of pens and notebooks, I must also remove the equivalent value of these 9 pens. And the equivalent value of these 9 pens is $16.20. So I'm going to cut off $16.20 from here. $16.20. Cut it from here. Or from here all the way backwards, somewhere here. This will be removed. So what is left here will be equal to $16.20 minus away $5. You will get $11.20. So this portion is $11.20. So what that means is that after you remove 9 pens from John or from Ginny, the total difference in value will be $11.20. All right. So total difference in value will be $11.20. This is number. Okay. This is made up of equal numbers. This 1120 is the total difference between the equal number of pens and notebooks. The difference between 1 pen and 1 notebook, I call it the difference in 1 group. Is 250 minus 180. And that will give you 70 cents. So difference in 1 group is 70 cents. The number of groups $11.20 divided by 70 cents. And you get 16 books. So there are 16 books here. The question is, how many notebooks did Mary buy? So this is the answer, 16. Let's look at question number 10.